Hello, this is Sumit Kumar Arse. Welcome to my YouTube channel. I am from DAVV IIPS and my roll number is IT2K2487 and my enrollment number is DE24022295. And today we are going to see our NAD internal 1 question paper, and in this we are going to see our question number 1. Okay, so let's see what our question number 1 is saying. Our question number 1 says write an algorithm or flowchart to solve the following pairs of linear equations for x and y. Okay. Given the values of coefficients a, b, c, p, q are okay, and our equation 1 and equation 2 are given. Okay. ax plus by is equal to c, px plus qy is equal to r. Okay. Here it is, we have given the a, b, c, p, q, r, and we have to find the values of x and y. Okay. And here down we are given the table. We have case 1 2 3 4 and values of abc pqr. Okay, and we also have the subparts of our question abc. We have to comment on the result of case 1 and case 2 when there is a change of 0.001 in one of the coefficient. Okay, and b, how interchanging of equations affect the solutions in case 3 and case 4. Okay, and c part, revise the flowchart or algorithm for solving with the case when one or more of the coefficient abc pqr are 0. Okay, so let's go. We will see our question with the Cramer's rule. Okay, Cramer's rule is basically based on the determinant. Okay, for step 1 we will compute our main determinant, that is d is equal to a into q minus b into p, and d is the determinant of the coefficient matrix, and if d is equal to 0 then the system will have no unique solution. Okay, step 2 we will compute our dx, and dx is equal to c into q, b into r. Okay, I mean c into q minus b into r. Okay, in step 3 we will compute our dy is into r minus c into p. Okay, and in step 4 we will calculate our x and y. Okay, now we will see our algorithm here. For this, our algorithm will be, we will start in step 1 and step 2 we will read the values of abc, coefficient of our equation 1, and pqr, coefficient of our equation 2. Okay, in step 3 we will check if any of the coefficient abc pqr is 0 or not. If so, then we will vanish that term. Okay, in step 4 we will calculate the main determinant, that is d. In step 5 we will check that d is equal to 0 or not. If it is so, then it basically has unique solution and we will print an error. Okay, and we will directly move towards step 9, that is our stop. Okay, if it is not, we will go to the step 6, and that is if d is not is equal to 0 we will calculate the determinant for x, that is dx, and in step 7 we will calculate the determinant for y, that is dy. Okay, and then in step 8 we will compute our x and y, and we will print the values of our x and y, and that's it. In step 9 we will stop it. Okay, now we will see our subqueries of this question, that is abc, and we will start this with our a. Okay, what our a is, case 1 versus case 2. Okay, effect of a 0.001 change in our one coefficient. Okay, case 1 and case 2 are almost identical. Okay, the only difference is that the q changes from 2.605 to 2.606, just difference of 0.001. Okay, this tiny change in coefficient can cause a different in result for x and y, and this phenomena is called our conditioning or sensitive of the system. Okay, Why this happens? Okay, this is also main question, why this happens. This is because the determinant, that is d, is very small and close to the zero, and the system is nearly singular. Okay, a small change in a coefficient can cause a large relevant change in our d. Okay, so this turn cause a large change our x and y. Okay, our key observation is that only this is called our ill conditioned, and d is similar to 0. This so this happens. And okay, now we will see our b part, in which case 3 versus case 4. Okay, effects of interchanging the equation. Nice. Now in case 3 we will take this equation 1 has a very small a, and in case 4 we will take this, and equation 3 and equation 4 are swapped. Okay, now see what happens when equations are interchanged. When equations are interchanged, the solution of x comma y remains the same, but swapping equation does not change actual solution. But this this will mainly affect the order, because floating points and arithmetic effects provided here by rounding off error, this will happen. Okay, when a very small coefficient like 0.2 like this, e minus 4 like this means, appears as a leading coefficient in Gaussian elimination or Cramer's rule, it leads to large round of error due to division by a near zero number. This is why pivoting strategies are important in numerical methods. Okay, now conclusion for this is that only interchanging equations pivoting can significantly improve numerical stability. Okay, always place the equation with the largest absolute coefficient first to minimize round of errors. Okay, and okay, now see our c part, and our c part is what? Reversed algorithm handling zero coefficients. Okay, C part is that if one or more of the coefficients a, b, c, p, q, r is 0, then the standard algorithm needs to be reversed here. Okay, here is the updated algorithm, we will see that, and this we will start with our step 1. Step 1 is that we will start. In step 2 we will read our a, b, c, p, q, r coefficients, and in step 3 we will check that if a is equal to 0, equation 1 has no x terms, and if b is equal to 0, equation 1 has no y terms. Okay, and if p is equal to 0, equation 2 has no x terms, means it becomes q y is equal to r, and if y, and it means q is equal to 0, equation 2 has no y terms. Okay, means px is equal to r. Okay, now in step 4 we will handle each specific case. In first, if a is equal to 0 and p is equal to 0, there will be no unique x exist, and in second we will, if p is equal to 0 and q is equal to 0, no unique y exist, and third, if a is equal to 0 and b is equal to 0, equation 1 equation 1 degenerates, and in fourth, if only one coefficient is 0, simply the equation and simplify the equation and solve the reduced system. Okay, now step 5, computing the d, and if d is equal to 0, we will print no unique solution and go to the step 8 and stop, and if not, we will do in step 6 computing dx and dy, and in step 7 we will calculate x and y and print it. Okay, thank you.